Good afternoon and welcome back to the workbench. Here we have a power supply, as may be obvious if you know what power supplies look like, or at least switch mode power supplies, which is what this is. This is out of my printer, in fact, a Lexmark T522. I bought this printer second hand a long time ago and it was working quite well, but then the print quality started to degrade and I sort of stopped using it a little bit. I ended up getting another second-hand printer, which is an Epson EPL 5900, and I've been using that instead, mostly for printed circuit board transfers, because you need decent quality for that, and if you've got, you know, random lines in the background or gaps or whatever, it's not very good for PCB layouts. So I was using that anyway, but I want to try and get this one working again that this power supply is out of, because I'd like to use it for other stuff, like printing shipping labels and other things that don't matter if the print quality is a bit bad. But I do need it to work properly, and I have another problem with it, not just not a great image, which I think might be fixable with some, like a new transfer roller and stuff, which is a maintenance error message it was throwing up the last time I used it. And I think there's maybe a couple of other rollers that need replacing as well. I know the fuser pressure roller is not in good shape, because I tried to print on a sheet of OHT which turned out to be not OHT, and it melted into the fuser and I had to pick all the little bits of melted plastic off the rollers. Yeah, so that's a bit sort of wrinkled, I suppose. Yeah, one of the rollers is a bit wrinkled, so I think that's affecting the quality, so probably need to replace that. Got damaged by that event. Anyway, that's not the purpose of this video. I'm just waffling now. As usual. Anyway, I had another problem with it as well as the funny print quality, which was that sometimes when I turned it on I would get an error message saying that the EEPROM was bad, or the NVRAM was bad, I think, yes. Like NVRAM checksum error or something, and if we turn it on and off a few times it would generally start working. I haven't actually used the printer, like I said, for several years now, because I was using the other one, and this one just ended up in the garage for a while, and I've finally dragged it out and was like, yeah, I want to try and get this thing working again. So anyway, the power supply here could be the problem. I don't actually know what the problem is. The fact that it would show that error like on a cold start on a cold day, and then if you switched it off and on a few times it would start working, it does imply some kind of heat sensitive fault, which of course could be a bunch of things. But a primary suspect obviously would be the power supply and possibly bad output capacitors, giving out low voltage or unstable voltage or something. So that's why this is here. I want to check this thing out. I want to check the capacitors, and I want to maybe load test it and see how it's looking. Yeah, see how it's going. This thing has 4 output rails, I think. It's a strange power supply. Well, not really that strange. It's just a standard, like, flyback switching power supply, I believe. But it has some interesting bits that are confusing, and I haven't noticed before. Well, I say that, but I think it's pretty standard. But it looks a bit odd from where I'm sitting. You might be forgiven into thinking this is actually an active PFC PSU, because you've got like 2 primary heat sinks, and then you've got this, looks like a transformer or a coil or something, and then just one filter cap, but it's actually just a normal power supply. You've just got a standard bridge rectifier here. These are just common mode interference filters. The capacitor is only 400 volts, and this device here, which you might imagine would be the part of the PFC circuit or something, is actually a triac, and that would be for switching the fuser lamp for the heat generation, and that goes through that connector there. That's why we have 2 fuses, because there's kind of 2 supplies on this board, really. There's the main power supply that does everything, and then there's the triac supply for running the lamp. So yeah, and of course, well, there's the high voltage power supply elsewhere in the printer that does the high voltage effect to stick the toner particles to the paper before they get melted into it. And that's not on this board, obviously. That's a separate supply, but I don't think there's anything wrong with that. I mean, there could be. That could be part of the print quality issue, but that doesn't seem to be. Well, that wouldn't cause the NVRAM error, I don't think. This, I'd be more surprised if the 5-volt rail output on this was, low or unstable or something. It would be more likely. This thing is about 22 years old. It was built in 2002, so assuming this is the original power supply, which it probably is, yeah, it's like 22 years old. And these are Nishikon capacitors, which are not too bad, PW series, so they're not bad. But after 22 years of good use, who knows? Who knows indeed? Of course, it could be something else. It could be the feedback circuit, could be bad, could be a lot of things. Yeah, so I'm going to investigate that, obviously. The other thing that's strange about this, though, is it claims to have 4 output rails on it. Or it seems to be. Because if you look underneath here, they've conveniently made a nice little space here. And I don't know if you can see the silk screen, but we've got a ground in the middle, you've got 5 volts above that, in the bottom we've got reg 24 volts, it's obviously regulated 24 volts, 42 volts below that, which I think drives the high voltage power supply, but I'm not sure. I think 24 volts drives the motors, and then up here we've got just 24. I don't know if the silk screen is showing up. So it seems we have 2 separate 24 volt rails. These are the transformer output pins. These are the primary pins, and that's the main capacitor there. So yeah, it seems we have 2 possibly separate 24 volt rails, a 5 volt and a 42 volt. But strangely enough, there's only like 3 rectifying devices on the output. There's this big diode here, single diode. I believe that runs the 42 volt rail, and I think this big capacitor of 50 volts is probably the filter circuit for that. Of course, I don't know because I can't see it yet. The 5 volt I'm assuming is this, because these are all like 10 volt caps here, these 3 here in a line. We've got a inductor there between them, so there's some kind of like pi filter going here. So they're obviously pretty serious about getting a good 5 volt rail. So if any of these caps were bad, you could definitely have issues with the 5 volt. And then there's a dual diode on this heatsink here, which I imagine would be the rectifier for the 5 volt. And then we've got a rectifier on this heatsink here, which is probably for one of the 24 volt rails. And you'd imagine there's another regulator and another diode pack on this side for the other 24 volt rail, but it's not, it's a transistor. At least according to the silk screen it says what does it say? Q2, in fact. And the markings do not show anything that makes sense for a diode, so yeah, it's a little bit strange. I don't really know what's going on, unless that is like a I mean, the only thing I can imagine is the possibility of the 24 volts comes out of this diode, goes directly to the unregulated output, and then this is like a transistor with a Zener to like regulate it to 24. But the problem is that that doesn't really make sense, because the output pins of the transformer show 2 different windings with 24 volt unreg and 24 volt regulated. Sorry, that's the other way around, but anyway, kind of odd. If it was a single rail that had a unregulated part tapped off before the regulator, and then you'd only have 1 output pin for that on the transformer. So I don't know what's going on there. I don't know how they're rectifying that second 24 volt rail, because it doesn't appear like there's any way to do it, unless they're somehow using this transistor. Maybe it's a MOSFET, they've got some sort of active regulation there. I don't know. Active rectification, I mean. Or there's maybe some surface mount stuff on the underside, I don't know. I can't see anything though, to be honest, if I look on the side, so I'm thinking this is all through hole, especially with all the wire links everywhere. So yeah, it's a bit strange. We've also got 3 opto isolators as well. There's one there, and there's one there, and then we got a 6-pin one over here. I'm imagining that one of them is for driving that triac, for the lamp, and then one of these has got to be for feedback, because this part here is a like shunt regulator, voltage reference IC. It's not a TL431. It's what was it again? It was something. Let's see. Oh yeah, it's this. The NEC UPC 1093. I'm pretty sure it's basically just a TL431. Well, it provides the same function anyway. And so that's obviously there, and then you'd have your opto isolator for that to drive the PWM control chip, which would be this 8-pin thing here, and there's our primary side transistor, which is there, switching the transformer there. But yeah, I don't know what the other one's for. I did see something about zero crossing detection, I think, on the pinout for the plug for this. So possibly that's what that is. It's some zero crossing detector to send a signal to the main board somewhere so it knows when to turn the triac on, which seems kind of strange. I don't know why you'd just not do that whole thing on this board, and the logic board would just send a signal saying turn on the lamp, and then this would handle the whole zero crossing part. So I don't know, it's a bit weird. Or maybe that's for the high voltage power supply for some reason. Could be some sort of signal for that, I don't know. There's no schematics in the service manual, unfortunately. The service manual only contains like mechanical diagrams and parts lists for all the rollers and drive belts and things that you'd need, and I think they have like a component overlay for the boards to show where things go, but no board view, no schematic, nothing else, which is kind of annoying. So yeah, that's fun. This PSU is a little confusing. I don't really know how the rectification is working and why there's 3 opto isolators exactly, but I suppose I'll find that out when I take this back plate off and I can see the traces properly. But first of all, I just want to test it and see what the voltages are. I just want to hook it up and do a quick test and see if the voltages make sense at all. But I realise I think I may have to take the the case apart anyway to find out where to actually plug this on. Yeah, I may actually have to solder a wire underneath or something to measure those rails, or I could just run it upside down, I suppose, or something. So looking at the underside of this board, it's still a bit confusing, but it's cleared up with some things. And I've also managed to mark a few jumpers, like here, 5 volts. Sure to tap 5 volts off there and measure that. And we got 24 and 42 over there, so I'll be able to have some probe points. But yeah, the strange part of this whole thing is the 24 volt connectors. I don't know how the heck that's actually working. I just guess I don't understand the circuit, but we have like this here, 24 volt reg. But the weird part is that comes directly from the transformer winding, and then it goes along this trace here, and then it goes directly to this land, and that goes to this capacitor, which is like a 1500 microfarad 50 volt cap, I think, or 35, I don't know, either way it's above 24, which makes sense. And then that just goes to this side is ground, this whole big trace in the middle is ground. This is a 24 volt output, and then we got a jumper wire that goes over here, another jumper, and it goes to a couple of pins on this connector here. Sorry, this is not in focus. There we go, you can see that. You've got 24 volts. I don't know what H1 and H2 are. They might be to do with the heater for the fuser maybe. ZC I think is zero crossing output. Obviously have 5 volt ground, all that. But yeah, there's 24 volts. Comes back from here, down here, and it goes directly to this cap, and then directly to this pin on the transformer. So I don't know. There's like no rectification anywhere along that trace, so I don't understand how that works. Obviously this capacitor hasn't blown up, so somehow it makes sense. I don't understand obviously the way the windings in the transformer work, but if we look at this other 24 volt pin up the top here, which is funny because this says reg, which I guess is meant to be regulated, but maybe it's something else. The 24 volt that seems to be implies it's not regulated, but I don't know in comparison. But that goes along this big trace here, goes to this dual diode for rectification, which makes sense, and then that comes along to that transistor Q2, which I showed before, and obviously that regulates the voltage. I assume there's no other reason why that would be there, I imagine. So that's probably a regulator based on, there's a smaller transistor here, another one, so I'm guessing this is like, you know, a discrete transistor regulator circuit, and that that's probably referenced with a Zener diode or something. And I believe the 24 volt drives the motors, but anyway, and possibly the cooling fan and stuff like that. But yeah, and then it comes through these jumpers, over these jumper wires here, through this middle point, and then it comes down to here, and one of the jumpers actually goes to that other trace that goes all the way back to the transformer on this side. So I don't know, it's it's very odd. I do not understand it. So I don't know, all the 24 volt pins seem to come through this one thing here, this one link there, and they're fed both by these links that come from the output of this regulator circuit, I believe that's what that is, and also directly from this side, which comes direct from the transformer. So I don't know how that works, because that is definitely the positive side of that capacitor too, and that's the negative side because that's the ground reference. So yeah, I don't understand that at all. Just when you think things make sense, suddenly they don't. That's just the way life is, I suppose. Anyway, so that's I don't know. Someone would care to shine some light on that? Someone who knows about these things? Maybe, well, I'm obviously missing something really obvious. Maybe if I drew up a schematic for it, it would make more sense, but just looking at it like this, I don't know, I can't figure it out. Anyway, but that's irrelevant. We should actually get on to testing the thing, and see if it works properly. So like I said, I've marked the 5 volt here. I can tap off that for probing. It does go via a pretty thin trace though. It's part of the powering the feedback, I think, or something. So obviously if I want to load test it, I'd still have to connect to this connector, and I'll probably just solder a wire to the underside here. These 4 pins are all connected to the same point. So yeah, but let's just do a voltage measurement first and see if we actually get 5 volts out of it. Because that's my suspect part. That's the bit that I'm not sure if it was working properly. And hopefully that's all it is. It'd be great if this was the problem. Because otherwise I have to take the printer mainboard out and possibly, I don't know, resolder the EEPROM or something, or maybe replace it, try and get a good dump and then replace it with a new one or something. I don't know. Alright, we have the power supply connected up. I have the multimeter connected to it. I've just hooked onto those jumpers that go to ground and 5 volts because that's the rail I care about the most, so we'll try that first. Got it plugged in. I just got to power it up with my transformer here. Isolation transformer, of course. Makes things a little safer. So let's see what we get. We do get 5 volts. It seems okay. Which yeah, I'm not kind of surprised, I guess. Anyway, that's interesting. It stays up for a while too. I've unplugged it. Yeah. That doesn't look like bad caps to me. If those were bad, that voltage would have dropped by now. Yeah, that's held up quite well. So I imagine that that's not the problem. I suspect that's not the problem, unfortunately. I didn't really think it was. I guess we can test the other rails here and see what they're doing. What else did we have? That weird 24 volt rail. Let's see, can we hook onto that? What have we got here? Oh, we got 7 volts, but it's not powered at the moment. So let's just see if we can hook onto there. Yeah, okay, let's power it back up. Oh, of course, that's over 24 volts. It's pretty much bang on 24 volts. I mean, the previous range is 20 volts, right? That's why I was going over range. Okay, well that looks fine, doesn't it? I mean, that's a little low, but you know, again, it's holding up pretty well even with the power off. Yeah. And now it's starting to drop, but it's dropping slowly. I wouldn't expect it's an issue there. Of course, remember this is unloaded though, so we do have to take that into account. I will do a little load test on the 5 volt rail. In any case, but what have we got here? 32. Lift that jumper a little bit. Okay, and let's have a look at that 40, was it 42 volt rail? Well, I expect that would be fine. That comes up a little slow, but then it's only halfway rectified, I guess, or whatever. I mean, that is slightly low, but it's unregulated completely, so I'm not surprised. Yeah, I mean, all these voltages seem pretty good. Unfortunately. Yeah. So it is looking like our issue may be elsewhere. Right, so we're going to do a little load test on the 5 volt rail. Just plug this in. Don't look at the multimeter here, look at up there. So we got 5.09 volts, and we turn this up a little bit. We can bring the current up to like 300 milliamps. 400 milliamps or something, and it's pretty stable. We're probably dropping a little because of the resistance of the wires and stuff, but I mean the voltage does not look like it's wavering under even some load. If the caps were bad, it would have gone bad by then, so you'd see that dropping far below 5 volts. So I don't think this power supply is bad. I think it's fine. So it looks like the problem might be the actual EEPROM itself, or something else with the main board, I guess. I don't know. Again, I don't know how much this is supposed to be able to supply, so I don't want to overload it or something, but it drops a little. Again, this is probably contact resistance on these. But yeah, it'd be good if I had this hooked up as well to show the actual voltage at the output, but yeah, I mean, it seems fine. I don't know. Go any higher? 500 milliamps? Like, yeah, this is stable, it's hardly dropped. Nah, I think this is fine. I don't think this supply is bad. At least not on the 5 volt rail anyway. The only thing that seems a bit odd is the 24 volt rail. If I put that on there, it shows a little low, 23.6, which also shows on the meter. And if I load that up a little bit, even 100 milliamps, it drops to like 20 volts. And 200 milliamps, it's like down to 16 volts. So that seems a bit weird. Maybe the 24 volt rail is bad? I don't know. Seems a bit strange to me. You'd think, I mean, something's got to drive the motors in that printer, unless, I mean, they don't run off mains, because this is the only mains input to the printer, and that goes directly to the power supply and the triac for the thing. So the motors must be driven from either the 42 volt or the 24, and 24 makes more sense, because 24 volt is a common voltage for motors and fans and things. And 5 volt will drive the logic, and yeah, like I said, the 42 volt might be for the high voltage power supply. I don't know. Unless I'm just probing a funny point on the circuit, but it seems a bit weird. Yeah, I don't know if that's an issue, so I might want to check the capacitors on the 24 volt rail and see how they're doing. Maybe there's something funny going on there. But yeah, I'm not really sure. It's a bit odd. I guess I'll try. If we go on the 42 volt rail, bear in mind I've just switched this off, so of course that's why it's dropping, but if I plug this back in, you know, there's our 42 volts, it's showing up as 38. If I give it a bit of load, I mean, 200 milliamps, it's dropped a little bit, but not as much as the other rail did. I don't know how much that rail is supposed to supply, so, you know, maybe it's not really a high current rail, but yeah, it's a bit odd. That's not dropping nearly as much as the other one. So who knows? Either I'm testing it incorrectly, or something else is wrong. But yeah, I think I will take the caps out of this power supply at the very least, and just check them, make sure that they're all good. Maybe the 24 volt rail ones are bad, I don't know. The 5 volt one seems great, at least on the voltage measurement. Of course I could check with the oscilloscope and see what that shows up, but yeah, certainly the 5 volt rail is what I'd imagine would cause that error message about the NVRAM. But yeah, I don't think the 24 volt, if that was bad, would cause that error, but who knows. Yeah, but there we go, that's something to look into, I guess. So yeah, we'll just investigate that. I'll desolder these capacitors and give them all a test and see if any of them are bad, because why not? I mean, there's only like 6 of them, and it won't take very long at all. So might as well give that a try. And I mean, yeah, if that's all fine, then I'll just clean all the dust off this power supply. There's a little bit of dust like on the primary side, because that's where the air intake comes. It comes through this bracket thing, and it gets, the airflow goes through the power supply and up through the back of the printer and out through an exhaust fan at the top of the printer. So that's obviously how they keep this cool. But yeah, that's very odd. Maybe these caps are funny, or at least some of them could be. So I'll investigate that, but other than that I can't see anything wrong with it. But apart from a bit of dust that has been pulled in through the air intake, and of course you don't want a lot of dust build up around the high voltage section, because if it gets damp or something, attracts moisture, it could become conductive, cause arcing and stuff. So yeah, if you find dust around the main side of a power supply, you should definitely clean that out, which I will do before I put this back in the printer. But yeah, I don't know. Without knowing the current specs for these rails or anything, like I said, the service manual doesn't tell you any of that stuff, I don't think. It's just, you know, it just tells you the pinout for the connector on the power supply, and has wiring diagrams and stuff of how all the boards are connected together inside the printer, but there's no schematic for the power supply, no schematic for the main board or the Ethernet board or anything. So yeah, I don't know. Anyway, we'll see. I guess that's that. Inconclusive so far, but we can at least test these caps and have a look and see what's going on, because I am mildly suspicious now of the 24 volt rail. It doesn't seem to be behaving that well. But then again, maybe it's just not a high current rail and it's not supposed to supply much power. Or maybe I probed the wrong point. I don't know. We'll see. Okay, well, I just had a bit of fun desoldering all the electrolytics and then testing them all and then putting them all back because they're all fine. Surprise, surprise. Basically everything is perfect. Yeah, capacitance and ESR is all great. The only thing, I even checked the main filter cap because why not? That's a little low at 300 microfarad. It's labeled 330, but that's the only difference. Maybe that has degraded slightly. I don't know. I wouldn't be surprised because it was the high voltage one. But I mean, that's nowhere near bad enough, and if that was really bad, the power supply wouldn't run properly at all, it wouldn't be stable. It might be power cycling or something, you'd get really excessive ripple. But yeah, no, that cap seems totally fine. All these other ones are totally fine. I even checked the one there by the feedback IC regulator, shunt regulator thing. That was totally fine too. I mean, the datasheet spec that as 4.7 ESR worst case, and it measured 2, so yeah, basically fine. Nishikon PR and PW series, they're all great. Nothing wrong with any of them, it would appear. So I didn't bother testing the startup cap because, I mean, if that was bad, then the power supply would power cycle or not start up, so, and that's not the fault. So I don't expect there to be anything wrong with that, and all the rest are perfect as well. So there you go. 22 years old, these things, and they're still basically perfect, except for this one maybe a little bit less than perfect, but also maybe just has looser tolerances because it's a higher voltage part. I don't know. But yeah, I guess unfortunately it looks like the power supply is fine, which sounds like a weird thing to say, but that means I got to probably troubleshoot the main board of the printer, which is probably much more annoying. These are easier to do because the faults are usually more basic and easier to fix because it's usually bad caps or shorted diodes or something. Anyway, the only thing I could really imagine that could be a problem with this, but probably isn't, it'd be if, maybe that shunt regulator, that voltage reference IC, was temperature sensitive, and when it got cold enough it didn't have a reference voltage that was correct or something, and then the feedback was off and the voltage was too low or too high or something because of it. But I don't know, I feel that's kind of pretty unlikely. Of course it's not impossible, but yeah, I don't know, this thing seems fine. And again, if the main controller was a bit flaky or something, if it wasn't starting up properly in cold weather, you wouldn't get that sound. The printer would power up, the lights would come on, the fan would come on, everything was consistent. There was no the fan wasn't fluctuating in speed, the lights weren't flashing. It was, everything was fine. It just says NVRAM error or whatever it said. So yeah, I suspect it's possibly more likely that the EEPROM chip or whatever that data is stored in is more likely to be bad, I suppose. So I don't know, I guess I'll have to look into that at some point, but I'll put this all back together, I'll clean the dust off, I'll put it back in the printer, then I can test the printer out and see if it's still got that problem. If it does, which I assume it probably would because it had it before, then I guess I'll be pulling the main board out and maybe I can test all the caps on that. According to the board layout in the service manual, there's about 5 or 6 electrolytics on that, so I mean possibly maybe a couple of those are bad or something. That could be a possibility. Or maybe there's an EEPROM chip that's failing somewhere and it's heat sensitive. So it'd be interesting to see what happens. Again, I think the printer does use some kind of BGA connected CPU for its main processing. So hopefully that's not cold solder joints or something, because I don't think I have the tools to rework one of those. And I've never actually done it before either. I haven't done any BGA work at all. So yeah, maybe that's an excuse to look into that, but I don't know. Anyway, we'll have a look. I think I'll... I guess what I'd probably do is take the mainboard out, and if I see any EPROMs on there, well, I'd test the caps first, I guess, if there are any, or any voltage regulators on there. If there's any sub-voltage regulators, who knows? I mean, it might run at 3.3 volts or something. Maybe the EPROM has a 3.3 volt regulator that's going bad or something. I don't know. Could be something like that. I have no idea, but that's all speculation. We'll find out, I guess, later on when I have a look at that. But apart from that, I guess this power supply is fine. That was not really a waste of time, but at least now I'm confident in saying that I'm pretty sure this is okay. The weird effect of the 24 volt rail being loaded is probably just me doing it wrong. Again, the topology of that rail is very odd, and I don't understand it at all. It doesn't really make any sense to me. If anyone knows how that works, please let me know, because I don't. But I was probably measuring at the wrong point or something strange, and that's why the reading was a bit off. But yeah, I mean, the point is the 5 volt rail I think would be the critical one for the digital stuff, and that seemed really solid. And yeah, I don't really see any major issue with that. So yeah, and again, the caps will test fine, so it's obviously not them. If there was an issue, it's something else. That's it for this one, I suppose. Not particularly interesting, but something nonetheless. And now I've satisfied my curiosity and given myself something to question and something to think about other than what I usually question about and think about. Anyway, yeah, strange output topologies of switch mode power supplies. I don't know. Anyway, I never did trace that zero crossing signal. I don't know where it comes from. Maybe I should have a look at it, just out of curiosity. Ah yes, just having a quick look under the board. It does look like it traces back to this opto-isolator here, which is interestingly labelled PT1 instead of PC1 like the other ones, so I don't know. Maybe that's a special opto-isolator that has zero crossing detection built in or something. I don't know, what is it? It's a 3SF21? I wonder if I can look that up. Yeah, there we go. It's a special opto-isolator with a zero crossing detection thing. I mean, it seems to be designed to drive the triac, so I don't know. Maybe the zero crossing pin on this connector... Sorry, you can't see that. Maybe the zero crossing pin on this connector is actually a signal in to drive the triac, and then this little chip here decides when to switch it. I don't know. Anyway, that's obviously how that works, but question remains then, what is that opto-isolator there for? Because that one is obviously for the feedback, because it's connected to that reference IC, and this one is, I don't know, maybe it's overcurrent protection or something? Could be to shut the supply down if there's overcurrent or over voltage or something like that, because there's no, you know, standby circuit and remote power up for this thing. It's literally, this is the power up, the main switch right there. That's all you got. So the printer has no standby mode. It's just on all the time if that's switched on. I mean, it probably does have a standby mode, but the power supply does not. It has no standby supply. It just runs the whole thing all the time. So yeah, maybe that's some over voltage thing or something. I can't imagine what else it would be. Yeah, who knows. Anyway, well, that's that for that one. Hopefully that was interesting. Maybe it wasn't that interesting because it wasn't really a fault, but who knows. Maybe things will get interesting soon when I end up pulling the main board out of that printer and seeing if anything looks funny there. Who knows. Anyway, hopefully that was at least enjoyable or something, and I'll see you next time. Oh yeah, so I decided to just try this. Free spray the feedback IC, and yeah, I mean, it doesn't really do anything.